Hello, hello, and welcome to a somewhat short stream for now, at least. Since I'm gonna do a lot of stuff later on. So we ended up during the last stream in a situation where we could highlight separate tiles. In terms of the movement system, we can actually move pawns around. And as I've mentioned, we should do some movement rules for each unit. So I've been contemplating how to do that. Unit moveset. And we could simply create a sort of dynamic system where where we had a movement system that was able to parse or calculate whatever moveset we wanted, but um, um, we could either go with the dynamic system, where we would have more data stored in terms of max x, min max x, for example, min max y, min max diagonal, for instance. Um, and then maybe a flag of combined or forced moves. Maybe something like a forced move set. For instance, the knight would have to, I think it's called a knight in English, would have to, for instance, move either 2 forward and 1 to the left or right, or vice versa in other directions. And that would, in general, not be possible to express with a series of with minimum and maximum values. Yeah, so for this system here, yeah, the knight Yeah, it's called a knight. The knight would have to be a special case where if we had a dynamic system, we would have to do a lot more calculations or flags or whatever. Um, yeah. So right now, a dynamic system is way more complicated and error prone. So we should probably just um, hard code it and create a method for calculating the possible moves. Yeah, yeah, like a switch statement of some sort. Yeah, I suspect that's probably the most elegant way to do it for now. Um, yeah, it will be generally more tricky. Uh, let's see. Let's just do. Let's just do a pawn for now. Okay. Let's just do a default. Yeah, as it will make more sense. It will also be 0. So we do something like that. And let's movement. And let's do a pawn. And when we create the game, uh, we need to add the move sets. Game moveset pawn, and let's do the same for the next unit. There we go. Hello, how are you? Unity is a game engine. So Unity is why don't I see the live chat here on my OBS panel? Oh, I had to scroll down. Sorry for the delay. I'm doing all right. I'm just doing a short stream here before I gotta go do some stuff. But yeah, Unity is a game engine, so I built my own game engine, or what do you call it? But so the benefit about using Unity is that you don't have to worry about programming a game engine from scratch, if that makes sense. Okay, so we should create some kind of like uh, well, I don't like actually doing a lot of heap allocations all the time. Um, this is heap allocating a lot. In general, I would like a cache. Yeah. I mean, it's not a lot of reallocations that we do since we only do it when we click. But an optimization would be to make a internal cache here on the game state. For instance, like the game tiles, we could do some kind of like uh, movement cache. This should also be probably a vector. Oh, whoops. Yeah. Let's see, units resize 2. Okay, so yeah, but this game is not very big in scope, so I guess we would do something like movable tiles. Maybe not tiles plural, but unsigned int x, unsigned int y. And then, even though I don't like it, we could do something like this. Calculate movable tiles. No, I just use Visual Studio. It has a built-in C++ compiler and IDE, as it's called. So, yeah, that's the benefit of using Visual Studio. It might be slow and buggy and stuff like that, but at least it gets you up and running in literally in minutes. Let's see, so game, moveset. Let's do a const here, moveset. Result, and let's return the result here. And let's do a switch on the moveset case. Break. Rather like this. Case game moveset pawn. Oh, I need the colon here. And we will let's just close so wait this. Yeah. Yeah, but that also makes it very slow compared to Visual Studio Code. So there are benefits to using code, but yeah, if you don't wanna fiddle around with setting up everything manually and just want something that works out of the box, yeah, definitely go with Visual Studio. I haven't dove deep into the whole build compile systems. I used a Linux box on GitHub from time to time, and you can definitely make it work, but yeah, it's more tricky. And if you're just starting out learning how to program or doing some tutorials or stuff like that, I probably think you would run with the IDE that has everything working out of the box. Okay, so this is probably going to split into a separate method. So in here, we clicked on a board tile. If we previously had selected a unit, grab the unit index, pass out. Well, uh, okay, and we update the. Let's see. We allow for several movements right now. This logic helps us do that because it doesn't deselect. But as you can see, this part of the code here doesn't highlight any available movement tiles. It just highlights the area under the unit. So for instance, if we remove this part of the code, when I click it and I move it, I am not able to move it any further. I have to reselect it. One could argue that you would just want to reset the whole the whole the whole movement highlighting, since you probably wouldn't be allowed to yeah, probably wouldn't be allowed to what do you call it? Yeah, I'm just thinking about maybe caching this instead, because I think that would give us some functionality uh, in the future, and would allow us not to make as many heap allocations. Okay. Yeah. Anyway, the way the game chess works is um, that you're not allowed to do any more moves than one. So yeah. Uh, okay, let me just implement it right away because this really annoys me. Game state tiles. Let's do a vector of unsigned ints. Tile original tile set. And maybe we want it split off in terms of the material here. This small chess like game. I don't know. Maybe I'll be done in a couple of weeks. I don't know if I have the time to work on it. Um, at least if I make a base chess game with a basic AI. But if we were to prototype something special where we do custom rules and a different game feel than original chess, who would know how long it would take? I mean, like, we would end up having duplicate data. Yeah, right now I'll allow for the duplicate data since this will be a cached original tile set, and we might change the I don't know. Uh, does it make sense? Does it make sense? Yeah, this is just a cache. Let's do something like this. Original tile set cache. So when we create our board, game state, original tile set cache, resize, yeah, we do the allocation right here. And equals to this entry here. Okay. So we can create the tile set. We will actually keep this method even though we're not going to use it right now. And instead we're going to do game state original tile set cached like that. So we won't be allocating on the heap every time we want to reset or whatever we want to do. Um, I don't know if I'm gonna publish it because who yeah, maybe if people wanna uh, play test it or mess around with it or yeah, whatever, I'll give it away at least for playtesting purposes. But yeah, I don't know. Depends on the whole scope of the project. I have a couple of ideas on project in terms of projects I want to do. So um, we'll see how far I'll get with this, and then um, but I really want to do some kind of or rather a different type of game overall um, as a more personal project. So yeah, this time I just want to finish something. Um, I don't know how long you've been following the channel, but let me show you the previous project I did here on the stream where I did, excuse me, everything from scratch. So we have this, um, what do you call it? Uh, uh, oh, whoops, I can't remember the shortcuts, so I crashed it. Let's see. So we have this shooter-like game with a physics engine. As you can see here, our buddy here fell down. Let me just reload. It's not much, but oh yeah, there's no collision for that kind of object. Yeah, and let's see. Uh, yeah, we also have, let's see, as you can see, shadows rendered dynamically. Uh, and stuff like that. And yeah, you can. Let's see, what's the shortcut? So you can see here the physics system highlights collision points and stuff like that. Yeah. So that's the previous project I built completely from scratch. So using no libraries at all. Uh, of course, inspired by a lot of different libraries, for instance, ImGUI and so forth, but everything is built completely from scratch. Um, also this extension. Um, but yeah, that project really had a lot of scope creep, and I realized during the development of that project that I really don't like doing a UI programming, for instance. It's not very fun because, yeah, it's basically handling a lot of pixel-based calculations and a lot of, yeah, at least to me, not very interesting logic. So for this project, I'm using ImGUI instead. And right now, that's the only project. I haven't implemented Microsoft's DDS loader yet, but I will. So, well, thank you. They're not very advanced, so you could do too. Uh, Thank you and welcome. How are you doing? Okay, so I'm digressing a bit. So whenever we want to uh, no, I'm not a software dev. I work within the healthcare sector. So I have a university degree in a health-related science and a specialization degree. You'll get there too, Oogie Boogie. Eventually, you will just think of how a computer works, and then uh, and you won't worry about referencing a lot of stuff. But yeah, it will of course take practice. Okay, so we will call this method here not no. What did I call the movable tiles or something? Movable tile. Moves. That's a neat name, right? Game state, units, and movesets. So we calculate our. Oh, wait a minute. This is actually when we do the movement. Yeah. Right now we won't mess around with this. We will just move it. And we will reset the state. Let's just see. But selected a unit. We clicked the same unit as already selected. I don't know if that sentence makes any sense. As we clicked the unit that was already selected. We clicked a new unit. Yeah, so this deselects okay. So right now I'll disable this. If you want to be a game programmer, I would highly recommend doing high-level physics. All science-based subjects I would take at an high level, a high level, as high level as possible, since you'll thank yourself down the road. Even if you go to university and you have the possibility of doing high-level maths and, or rather just linear algebra and stuff like that, I would definitely do that. Okay, so Yeah, I should probably rename this just so it gets easier to read here. Yeah, maybe not biology, or for that matter, chemistry. If you want to go into computer sciences, math and physics are complementary in terms of that science, I think. But I'm no expert. It seems like you're talking about the American educational system, am I right? And I have no experience in terms of that education system. I'm from Europe, so what you would want to do is probably different from what I would want to do if I ever had to do university and getting a degree all over. Okay, so um, okay, so maybe we want to combine these two. Oh, okay. I know even less about that educational system. Okay, let's do a function call here. Create a highlighted. Create highlight. Maybe. Yeah. Uh, create movement. Movable highlight. Maybe just move highlights. Um, I just decided to build small projects for fun, um, and did some different tutorials. I generally wouldn't recommend going too deep on tutorials, but just rather experimenting with building something and diverging off the written path, so to say. Thank you, man. All right. Catch you later, buddy. So we will create a series of movable highlights. Maybe we want the I'm not a I'm a hobbyist, so I don't really know how long I've been coding for. Um, since there's been breaks where I haven't programmed for maybe half a year or maybe a whole year or something, and then I got back to it. But I think on off I've been programming for a couple of years. So we will get our movable tiles here, and we could do something like, since we already cached our original tiles, and we get a vector here with movable tiles. Uh, I was considering actually doing an index, but anyway, so we will get our original tile set, which we actually cached right here, and we will copy our original tile set, and then for each of our movable tiles, uh, we will, let's just do like this. It gets more readable when we're doing pointers. Let's do an unsigned int index here. Maybe we just want a game state. Since it will hold both of the original tile sets. Yeah, let's just do the game state then. Game state. Oh, whoops. Whoops. There we go. Yeah, because we need the information here in terms of the game states, since it could have a different chessboard size. So let's do y times game state. plus the game state here. So we would take the amount of columns per, whoops, no, not like that. We will take the amount of columns per each row and multiply it with the y, which is the amount of rows in our array, and we will add the x value to it here, and we will know which index we have in terms of the underlying array with our tiles. So now we can do something like result index and set it to whatever value we want to. Okay, so this should create a series of highlighted tiles. So let's try out this method. So highlight unit movement. Okay. Well, it wants a... Oh. No. Oh. We could actually compile it into this instead. I totally forgot that. Yeah, okay. We could do actually either, but our renderer takes materials. Okay. Yeah, create highlighted tile set. Yeah, this basically translates whatever. So yeah, we don't need to do that. Okay. Let's see, calculate, create, move highlights, game state by reference. Moves. Let's simply overwrite this. Right now it won't do anything, but yeah. We also want the we want the original X and Y. Huh. Am I doing a lot of duplicate work here? No. Because we will know the origin of the moveset, we would also want something like a player. Let's see. Just a moment. Yeah, so okay, let's just do some testing here. And we set the origin x plus 1, y or origin y plus 1, and then we add that to our vector results. Okay, it definitely doesn't work, but we do get a diagonal tile. Whoops, I don't know. Yeah, I have to iron out that bug eventually. I don't know why. Oh well. It's probably, oh, I know why. It's because we're right now doing something out of bounds. Yeah, so you get crashes like that when you operate in um, the wrong parts of the program's memory. But yeah, okay. Let's see. So we did a successful highlight actually. Um, since this is the a plus on the x and plus on the y, it makes sense. So whenever we calculate a movable, what do you call it? Movable, whoops, that's not the right one, I think. I would like an enum actually. We could do it inside this CPP file, or I don't know. It's not very important. Anyway, so we calculate some movable tiles. We highlight them with a color of green, and we know that that tile is quote unquote movable. Right now, we do not have any checking in terms of checking whether this is valid. This could also be cached. Moving an object is not something that we will do very often, which also means that the heap allocation here probably doesn't matter too much. You could do something like reserve and make sure that you wouldn't resize too often. But then again, for small allocations, maybe you could do it like here a pawn can, well, move like 2 uh, spaces. So that would mean that this would all need to be 2 movable tiles. Anyway, Okay, we need to expand this. Hi there, how are you doing? With something like an unsigned int player, since game state player. And let's do a no problem. No, I haven't used OpenGL. Okay, so player mod equals player. So if it's true, -1, otherwise it's just 1. For instance, here we can do something like movable tile. It's not unsigned int, right? Oh yeah, it is. But doesn't matter because the end result is like that. So it doesn't work, but yeah. Let's swap these actually. Now I'm pretty sure it's down here when I calculate the yeah, that's out of bounds. But now that works. Okay. Yeah. So we need to do some bounce checking. I'm just um creating a game completely from scratch. So chess was a pretty easy starting point. I want to make a kind of like chess-like game um, where there are different types of units and rules and a different gameplay feel than ordinary chess. But I'm starting out by actually doing the original chess since um, it will be a fairly limited scope and yeah. Um, and it will, since I'm creating everything from scratch, it will kind of like illustrate what game systems you would need uh, to build around in terms of rendering, game logic, update cycles, and so forth, controls. Okay. Yeah, in terms of the original chess, yes, of course, but I'm unsure what would be done down the road. Um, you could imagine some kind of like upgrade where maybe we don't need to pass in this anymore. We could simply just do update the case. I'm not sure. What do you mean? Actually, we don't need this either. Actually, we don't need this either. We can simply grab it from our game state. Well, Oogie Boogie, it depends on what you would want to do. Um, yeah, but that's all right, but I didn't understand your question. Let's see. Oogie Boogie, if you want to learn how to build a game engine slash a game completely from scratch, I would learn C, since it's a systems level programming, and a game engine and a game built completely from scratch is mostly a lot of different systems where you need to understand how computer memory works, how different allocations work, how different algorithms work, how optimizations work, and so forth. But if you just want to make a game and don't really care about um, learning how to build things from scratch, but you just want a functional game, and um, um, you want to like go more into the game design side of things, then you should use something like Unity, where the game engine is actually built for you, and you only have to learn some kind of scripting, uh, and thereby learn C sharp or whatever. Yeah, C++ is fine. The problem with C++ is that um, that it doesn't always teach you how a computer works, and it ends up getting overly abstracted and more error prone, in my opinion. But I'm no expert, so don't mind me anyway. So instead, we just pass in the unit index and our game state, and we grab our move set directly out of that, and we can also access our active player. Let's do the player mod still. Okay, because I need the game state to be able to calculate the restrictions. Yeah, OpenGL is a great choice. OpenGL and DirectX11 are probably the best choices if you want to just be able to do stuff. Yeah, I'm more interested in the engine part of things and performance issues. So Yeah, that's a great choice. OpenGL is generally good. And depending on what you want to do, it's more or less the right choice, but yeah. Anyway, so um, we need some kind of logic. Let's see. We don't need this right now. So let's imagine that our current player here is player 0. The blue player here is the one that starts the game. So 0 means that the x and y, if we're moving forward, is actually negative. So let's just just do the I think you can do C and C++ and C# in most standardized workloads. So just do some console application workloads. Player 0, blue player, forward is negative x and y. Player 1, opposite. Okay, so maybe we could do some kind of like small function here is within bounds game state. Let's do a max x. Game state. Yeah, maybe I don't want to do that actually. Just let's do return. Tile columns. This will always be one larger, so y less than game state. Okay. I know this will be overly verbose, but just in terms of readability, I'll do unit index here. The compiler probably will collapse this into something more elegant. Okay. Origin. A pawn will be able to move forward for 2 spaces. So let's add a temp tile x origin x plus 1 times the player mod here, and the temp tile y is equal to the origin y, and we push back that. Okay. We of course want to do something like if is within bounds, game state, okay, let's store this. So I don't have to do it all over. Move 1. Move 1 Y. There we go. Return results. Thank you. Thanks for dropping by, Sleepy Mushroom. Sleep tight. Hopefully I'll see you around here on the channel. So if the X and Y is without outside the bounds, we simply return. Otherwise, we move along. Okay. Oh, I moved the pawn right over here. Let's see. Out of bounds. Let's just see if this happens. Okay, it doesn't even trigger, am I not? All right, now it says out of bounds for some reason. But now it doesn't. Oh, it's because... Let's just see. Does it even trigger? No, it's not triggering. Let me just see the call here. I probably made a mistake somewhere. Wait a minute. Start index is different than the unit index. That's why. Yeah. Yeah, the start index here is actually not needed anymore. There we go. It's definitely not. It's because I immediately know what I'm. It's not the X. It's of course the Y. Anyway, okay. Out of bounds. That one works correctly. Oh yeah, it's because we haven't swapped players. So this is correct. If we swap to the other player, it will. Yeah. Okay. Well. Okay. Oh, I really don't know, buddy. I really don't know. Hello, I'm doing a game. Hmm. Okay, let's do something. Um. Okay, so if we are the active player, uh, well, something went wrong here. How do I actually set the player state here? Not up here. When I create the game, player 0, player 1, and the blue one is player 1. Okay. Okay, let's swap these. There we go. So this one won't work. Oh, yeah, there's a part about the reset logic. Anyway, if I do, yeah, okay, so parts of our logic here works now. We've of course made changes. Otherwise, we want to there we go, this one. So we didn't click our own pawn, and it's ours. There we go. Yeah, okay. And let's do maybe just the origin y. Maybe this is wasteful. Okay. There we go. So if we're allowed to move, there we go. And if we move up to here, we're still allowed. And now it has bounce checking. So it only tries to create that. We would get a crash if we were trying to modify something that is out of bounds. So this works perfectly. Whoops. We can still move the other player pawns. Yeah. So that's it for the actual calculation of the movable tiles. And we can, of course, yeah, you could cache this as well. So to avoid reallocations, but since we're not doing this on a per frame basis, we're doing this once and then we're updating the whole rendering state. And whenever we deselect something, we're updating the whole rendering state again, but it doesn't happen on a per frame basis. So therefore, there's no real need to cache it. I mean, this had to be computed every time we clicked on something, and maybe even several times per click. It's not a very good optimization, but yeah, I just wanted to do that, even though these old functions here are probably not much slower. Anyway, I did this because I would probably want to be able to modify each board piece perhaps down the road. And I would want the original state Um, yeah, I don't know. Maybe it doesn't make any sense. That's the problem about doing stuff like this, which you haven't done before. Sometimes you realize that you've done something wasteful or suboptimal or did some optimization prematurely. So yeah, try not to get distracted too much in terms of what's best to do. Okay, so this calculate movable tiles now highlights the actual movable tiles. Um, and we can, of course, reuse this function. Let's remove all of this old stuff here because possible. And let's just rename this highlights. Reset board highlights. Okay. The same thing goes for here. If we click outside the whole thingy. Anyway. Okay. So if we actually want to perform the movement, we could check the player's active player in the player state to prevent any bugs. But we don't for now. Okay. We have the unit index here. And we want to calculate our possible movable tiles. And then we want a possible flag. If possible, we do this. The X and Y is not needed, I think. Okay, and we simply iterate fork const auto reference move. Maybe just, I don't like auto. Let's see. Isn't it? Const auto. Oh, of course. Move. There we go. Silly me. Move. Oh, we actually want this. And we maybe want it inside this. If the x equals move.x and the y equals move.y, true, break. Okay. So, okay, doesn't move anything. Let's see, checked. Move x versus move y. Okay, it doesn't register. Actually. Let's see. Unit index. Unit index 1. Okay. Let's do moves that size here. Moves 2, so let's see. Let's just check here. Oh! For some reason it works. Oh yeah, of course. We only check for the first one. That's the problem. Okay. We also Yeah, how do we solve that? Wait a minute. Let's see if we do something like clicked X position. Is it because I clicked position 0, 0? Yeah. Clicked. Okay. Let's reset the state here. And if I click here, clicked position. Oh. 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 Whoops. What a silly mistake. Anyway, it was working all along. I just needed to move the whole break inside the actual check here. There we go. So now we can move our chess piece within the restricted movement. Great stuff. So we can select our own pawn, but not our opponent's pawn. We can click on it. So if we wanted to check the stats, for instance, of this chess piece here, um, we could. We can move our pawn here within its restrictions due to its calculated um, movement restrictions. So if I click here, you can see I just deselect the pawn. Yeah, I should probably reset the whole thingy. So if I previously had selected a unit, oh, this needs to be done right here. So yeah, I can deselect the pawn. Also, if yeah, okay, great stuff, great stuff. So we have basically implemented the movement system for a pawn. Um, and whatever movement restrictions we have for each type of move sets um, gets handled in this method with a bit of bounce checking as well, and the highlighting of the available moves are dynamic. And yeah, yeah, so we actually did what we set out to do. We do not have uh, any specific special case movement sets, but we can always just handle that kind of logic in our method. Update the selection for IE debugging. Could be skipped if we're in runtime mode. Okay. Next, what do we need to do to be able to create this, what do you call it? Um, we need a attacking system. So we already have a highlighting system, we have a movement system, we have bounce checking, we have different stuff that we can use to handle our game logic. So next thing should be something like, let's move this pawn, let's move this pawn again, and then select this pawn. Okay, so these should be able to attack each other. Yeah, right now they're not allowed to attack each other after we implemented the movement restrictions. Yeah. Anyway, I gotta go do some stuff. So therefore, I'm gonna end the stream for now. Maybe I'll be back tomorrow. Maybe I'll um maybe I'll do some more work today. Anyway, I think it was some decent progress. I think it was some decent progress. Yeah. All right. Thanks to everyone who tuned in or interacted during the stream by chatting or liking or whatever. It's always a pleasure to see people joining the stream and hanging out. Yeah. So that's it for now. Hopefully, I'll be seeing you around. Feel free to join the Discord server or uh, join future streams. Uh, please take care, everyone, and hopefully, I'll be seeing you around. Bye bye.